Okay, this video is a video about multiplying monomials times monomials. A monomial is simply one term. For example, if you'll notice this right here, 9x squared, that is one term, and we're going to be multiplying it by 3x to the third power. That's also one term. In this video, I'm going to show you the mathematical meaning of multiplying a monomial times a monomial. Basically, it's spread out to help with your concept or understanding. And then I'm going to show you the same problem and an easier way to remember. Okay, let's start by remembering in your guided notes, we learned that when multiplying polynomials, you always, regardless of the format, multiply the constants or coefficients. Constants and coefficients, basically they're the big numbers. For example, this 9 and 3, they're the big numbers. The 9 and 3 both are multiplied by a variable. Therefore, the 9 and the 3 are the coefficients. If the 9 nor the 3 or the 9 or the 3 did not have variables, they would be constants. But right now, we're going to end up multiplying the coefficients. When we multiply the coefficients, we're then going to add the little numbers or the exponents. The exponents are always the little numbers. And before we begin, I want to remind you that every single variable has an exponent. And if that exponent is not shown, it is 1. Let's start with this first two monomials. We have 9x squared times 3x to the third power. All this means is 9 times x times x. 9x squared is the same as 9 times x times x. And then 3x to the third is the same as times 3 times x times x times x. So all you're doing is you're saying 9 times x times 3 times x times x times x. And remember, in multiplication we can rearrange this. So we can rearrange it to be 9 times 3 times 1, 2, 3, 4, 5. There's 5 x's, so we can do it x to the 5th. So 9 times 3 is 27, and 27 times x to the 5th gives you 27x to the 5th. Now guys, I know this seems long and drawn out, but I wanted you to understand that 9x squared times 3x to the third is the same as 9 times x times 3 times x times x times x. Well, we can rearrange that so that the constants are multiplied by each other. The coefficients. 9 times 3 is 27. And 1, 2, 3, 4, 5, there's 5 x's, so that gave you x to the 5th. So your final answer was 27x to the 5th. Now here's an easier way. What I like to say, again, multiply the bigs and add the littles. Well, the 9 and the 3 are the big numbers. So 9 times 3 is 27. The variables that are included, the only variable here is an x, so we go ahead and write the x down and add the littles. 2 plus 3 is 5. Now that's a bit shorter, but I did want you to understand what the concept behind multiplying the monomial times the monomial. Now let's look at number 2. We've got 6a to the third power times negative 2a. Again, remember, what's the exponent of the a? The exponent of the a, there's only one a, so it's a to the first power. So let's write this mathematically. We have 6 times a times a times a times negative 2 times a. So what we've got is 6 times negative 2 is negative 12. We've got the variable a, and we've got 1, 2, 3, 4 a's. So your answer, negative 12a to the 4th. Or the easier way, 6 times negative 2, you multiply the bigs, gives you negative 12, and you add the littles, it's a. What we can't forget here is our little 1. 3 plus 1 is 4. So that is your final answer here. This isn't very hard. Let's go ahead and hit these last two, and then we'll be ready to rock and roll. This time we have three monomials multiplied by each other. That's okay. We can have as many monomials multiplied together as possible as we want, but the concept is the same. We've got negative 2 times x, and there's only one x, times y times negative 3 times x, there's only one x, times 5 times, there's 3 y's. 1, 2, 3. So this is the way it's shown out mathematically. Now all we have to do is multiply our big numbers. Negative 2 times negative 3 is positive 6. Positive 6 times 5 is 30. We have the variables. We have both x's and y's here. Ask yourself how many x's. We have 2 x's. How many y's? 1, 2, 3, 4, 5. We have 5 y's. So what we have is 30x squared, y to the 5th. And that's our final answer here. Now, the easier way, we make sure all variables have an exponent. So we've got to put a little 1 above this x. We've got to put a little 1 above this x. Now we multiply the bigs. Negative 2 times negative 3 times positive 5 gives you 30. We have both the variables x and y, so we go ahead and write those down. X's, 1 plus 1 is 2. Y's, 2 plus 3 is 5. Then finally, down for number 4, we've got p's and q's. It doesn't matter, we do them the same way. Mathematically, or like the way I like to call it, a little bit of the long way, but that's okay. To expand this out is the same as 3 times p times p times p times p times p times p times q times q times q times q times q. How many q's do we have here? That's 1, 2, 3, 4, 5, 6, 7, 8. See why my method is easier? Now we still got to multiply it by 6 times p times q times q. Whew, that's a hot mess. You see why my method is so much easier? But anyway, all you've got to do is say 3 times 6 is 18. We know we're going to have both a p and a q in our answer. Let's look at our p's. We have 1, 2, 3, 4, 5, 6, 7 p's. So it's going to be p to the 7th. Q, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 q's. So our answer is 18p to the 7th, q to the 10th. Or, multiply the bigs. 3 times 6 is 18. Make sure all the exponents have, all the variables have an exponent. So we got to put a 1 here at this p. It'll be p. 6 plus 1 is 7. Q. 8 plus 2 is 10. Guys, I hope this helps you better understand how to multiply a monomial times monomial. In the next video, we're going to learn how to use the distributive property to multiply a monomial times a polynomial.